I'm the research advisor here at CSD. Most of my focus before CSD has been in paper making and in bioprocessing of Casuarina as a feedstock for biofuels, so anything from hydrogen gas to ethanol. Part of this semester, we've been looking at using Casuarina instead to make like textiles or clothing, things that would traditionally be produced from like either animals or from petroleum. So I'm going to introduce my co-advisor, which is Alex.
Morning, everybody. I'm Alex Cook. I've been on the Island School faculty for nearly 5 years now, and I've been a research advisor for 5 different CSD research projects, and I'm super excited to have our students talk about what they've been up to this semester.
Welcome, good morning. We're the Casuarina research team, and the title of our presentation is Casuarina Textiles Bring Out Invasive Species. I'm Dylan.
I'm Sam. I'm Daniel. I'm Sam. I'm Sophia.
Okay, so throughout the semester, we have been working towards creating sustainable, eco-friendly, and renewable products from the Casuarina biomass. And while working in the lab so far, we've been successful in creating paper and extracting fibers from the Casuarina. Our initial goal was to take the Casuarina fibers and use them to create clothing while partnering with Studio, which is an eco-friendly clothing company based in New York City. They are actually partnered with the Island School and produce most of the clothes that we have in the school store. But since the beginning of the semester, we've actually decided to stray away from the clothing idea due to the fact that it takes and uses a lot of chemicals to produce the clothing, whereas just making paper is a lot more sustainable and eco-friendly. And our 3 main research objectives are finding ideal soil pulping conditions for Casuarina biomass, investigating biomass feedstocks to produce bio-based products, and how to convert invasive Casuarina into a fiber suitable for making textiles.
An invasive species are organisms that grow outside of their native range and spatially compete with other native species due to their high reproduction rate. Typically, they have no natural regulators, which makes it very hard to eradicate or manage them. The 3 most common types of invasive species in the Bahamas are lionfish, Casuarina trees, and cane toads. Casuarina trees are brought in from Australia to the Bahamas to be used as an ornamental plant, a windbreaker, and to stabilize sand beaches. Casuarina tree leaf litter acidify the soil and areas around them, as well as block sunlight from other species of plants. Therefore, it makes it very hard for juvenile plant species to grow. In the Bahamas, Casuarina trees disrupt mangrove ecosystems. This is detrimental because mangroves serve as nurseries for fisheries on the island. Additionally, Casuarina trees accelerate beach erosion due to their shallow root systems that topple over during high winds. This is also very detrimental because beaches serve as a very big tourism product, as well as natural protection during storms. So Casuarina trees are actually a very sustainable forest product due to their high growth rate. Therefore, there are multiple benefits to managing Casuarina trees and turning them into textiles or other bio-based materials. Unlike other feedstocks such as cotton, Casuarina trees actually don't require any irrigation or pesticides. As an alternative to cutting and disposing, we'd actually be able to manage where Casuarina grows for economic activity as well as a constant supply of raw materials. Casuarina trees also have a much higher standing biomass density compared to other sources of fibers such as cotton, hemp, or bamboo. However, there are some cons to managing Casuarina trees, such as possible seed dispersion during transportation to processing facilities, as well as there is a law stating that we're not allowed to cultivate Casuarina trees in the Bahamas.
As we potentially enter the textile industry, we want to be fully aware and knowledgeable of the industry as a whole. Second to the petroleum industry, the textile industry is the 2nd biggest polluter of the world. The image in the center depicts a river being polluted with harmful chemicals to the environment and to humans. And the image on the right depicts a landfill where materials cannot be recycled back into the earth properly. The human impact is another concern we have. The industry is notorious for exploiting labor in countries with lower wages. And that being said, at this project we have the opportunity to create a new industry on the island itself. That means that we want to take a new path and follow fair trade values with labor and use renewable materials for our project. These 2 companies are proof that these types of companies can be commercialized and work. Pinatex creates sustainable materials with pineapple fibers, creating leather, and Myco Works uses mushrooms, mycelium, to create leather and bricks out of mushrooms. Both of these companies are using renewable materials and treat the workers with fair labor values.
Before going deeper into our research presentation, a few key terms must be defined. First being biomass. Biomass is all organic matter such as plants, wood, and any agricultural waste. Second is biomass pretreatment. Biomass pretreatment is the process of separating the 3 sugars that Casuarina have. It is lignin, hemicellulose, and cellulose. Our third is soda pulping. Soda pulping is our process where we soak the Casuarina wood in sodium hydroxide, and then we cook it at a temperature of 100 degrees. We do this particularly because the soda pulping pretreatment is very cost effective, and it also is more accessible than a lot of treatments on the island. Our last is H factor. H factor is the system that we use to test the effectiveness of our soda pulping, and we do this by finding the temperature and then the relation of time.
So the first step to our soda pulping process is the biomass preparation. As you can see in the photo on the far left, our group went out in the field one day and helped fell a tree. So once the tree is felled, we then cut it up into smaller logs. And if the logs are small enough to fit into the wood chipper, they are then processed into 2-inch long wood chips, which are then left to air dry for 12 to 24 hours. The next step is the white liquor preparation. White liquor is sodium hydroxide powder dissolved into distilled water. The 3 main concentrations of this that we use are 15, 20, and 30%. And how you would make a 15% concentration would be 150 grams of sodium hydroxide powder and 1,000 milliliters of distilled water. Once the white liquor is prepped, 30 grams of wood chips must be soaked in it for 12 to 24 hours, and Dylan is going to pass around some samples of that. So we have the 30 grams of wood chips, we have a paper sample, and we have some soda pulp. So our soda pulp process generally lasts from anywhere to 80 to 100 minutes at an average max temperature of 148 degrees Celsius. Every 5 minutes we measure our temperature, as seen in this photo here. We measure temperature every 5 minutes, and we take black liquor samples, as seen in that photo there, every 10 minutes to measure density and pH. And once our cook is done, we end up with a pulp slurry, which looks something like this. And we then have to wash it in order to get it to look more or less like this photo here. And so in order to do this, we wash it with 4,000 milliliters of hot distilled water. And so that is basically removing all of the black liquor which was produced through our soda pulping process, which gives it its dark color, because it is lignin rich, and lignin is what actually gives wood its like brown color. And so once it is fully washed, it turns into this light white color, and it is more fluffy than it is when it starts off. And so then we take 2 gram samples in duplicate to measure moisture content and percent yield from what we started off with. The next step is the paper making. Once you have finished with your pulp wash, you then put it into a blender for about a minute with distilled water and until it's fully blended. And the next step is to pour that across a decal in order to make a pulp sheet. The pulp sheet is then manually pressed in order to dewater it. And then once it has been fully dewatered, we hang it up to air dry for about 24 hours or until it is completely dry.
I'm going to cover the results and analysis of our experimental data. The blue line represents the theoretical rate at which Casuarina delignifies, and everything under that blue area is our theoretical H factor. The red line represents our data, and the reason that our red line does not match up with the blue line is due to the fact that our lab is an open environment, meaning that there is volume loss when we're conducting the soda pulping. And in order to make up for that volume loss, we have to add white liquor, which is room temperature, and that throws off the constant temperature. This graph depicts our temperature in terms of time. As you can see, when time increases, so does the temperature. Our average max temperature was 148 degrees Celsius, but our desired temperature was 160 degrees Celsius. This graph depicts our black liquor pH. Our initial pH was 12 and our final pH was 13. The reason that the pH rose from 12 to 13 is due to the fact that the hydroxide molecules that binds the Casuarina together left the Casuarina wood chips themselves and went into the black liquor. The picture right here is samples of our black liquor throughout one experiment. As you can see right here, this is white liquor, and as time went on, it turned into black liquor. And also the density within the liquor increased. These tables represent two different experiments, one 100 and one 80-minute reaction time. We averaged our average pulp yield was 37%, and since we started with 30 grams of oven-dried wood chips, we only got 11 grams of oven-dried pulp. We chose to use the 80% reaction time because it gives more consistent results than the 100-minute. This image depicts the Casuarina in the different stages of the soda pulping process. The first sample is 30 grams of Casuarina wood chips. The second sample is the digested wood in the midst of the cooking process. And then the final one is the Casuarina soda pulp. The true cost of our project is that we used 166 liters per kilogram of pulp, 306 kilowatts per kilogram of pulp, and $104 per kilogram of pulp. The reason that the cost was so high is because in the Bahamas, energy cost is 5 times higher than the average cost in America. For future studies, the Casuarina project hopes to continue on soda pulping, but the reason we're not going to make it into other textiles is due to the fact that the next step in making those textiles is very chemically heavy, and we hope to be as sustainable as possible here at the Island School. We will continue doing the soda pulping, and we're thinking of adding coconut fibers because they're much longer, and the Casuarina pulp by itself is very short and cannot be spun. We are also thinking of using mycelium, which is fungus, so we will grow fungus on the forestry waste. That includes the pine needles, the branchlets, and basically everything that we don't use for the wood chips in order to create other products like cement blocks and packaging. Before we finish our presentation, we'd like to acknowledge a few people that helped us along the way. Of course, our advisors, Carencia Studio, our CSD team, Joe Plant, Joseph, Johnny, Jacob, Nathaniel, and Sam, and of course, all of you guys for listening. Thank you so much. This is our cited literature, and are there any questions? Yes.
I'm just curious if it's against the law to harvest the trees, how will you continue researching this project? If it's against the law, did someone say?
So the question was, if it is illegal to, or if it is against the law to harvest the trees, how can we go on with this research? So the law states that it's illegal for cultivation. So that basically means that it would be illegal for us to go back and replant it through, like, as if we are planting a crop. So we are allowed to harvest it, but we're not allowed to cultivate it.
Is black liquor recycled, or what effect does that have on the environment once you're done with the process?
So the question was, is the black liquor recycled, or what effect does it have on the on the environment?
Okay, so that is the main reason why the soda pulping process is not very environmentally safe. That's because we cannot recycle the black liquor. is very dense and it cannot go back into the earth. So that's the chemically heavy part of our project, and also the fumes that come from that soda pulping process.
And to add on to that, the black liquor is, or the main thing in black liquor is the sodium hydroxide, which isn't it isn't toxic, but it is caustic. So it burns to the human touch, but it isn't that toxic. In the back there.
So, how much paper did you produce in this project, and have you implemented the use of it in anything in particular?
Could you repeat that? Sorry.
How much, throughout the project, how much paper did you actually produce, and are you using it for anything in particular?
So the question was, throughout our project, how much paper have we made, and are we using it for anything?
So the paper was actually originally used to test out the different combinations of fibers. At one point we added coconut fibers into the Casuarina. We pressed paper to see how it would come out. And we haven't had that, we don't have a large quantity of paper, but we've produced around like 15 sheets of paper. But the main purpose of them is to test out fiber combinations.